Hi, my name is Radhika. Welcome to my additional mathematics classroom. Today we will solve this paper, 2021, May-June, paper 12.
Let us start from question number 1. A fraction is given in P, Q and R. We have to write this in the form P power A, Q power B, R power C, where A, B, C are constants. So the given expression is P, Q, R whole power minus 2, then multiplied with R power 1 over 3. This divided by P square R whole power minus 1 multiplied with Q power 3. Now here we need to apply the rules of indices, that is, when a power m whole power n we have, then we can write this as a power m multiplied to n. So we will apply this formula. Okay. Then the second one that we need is a power m multiplied with a power n. When the bases of two power notations are same, then the base remains the same. We will just add the indices. So it becomes a power n plus 1, n. Similarly, a power m, a power n, bases are same, different indices, and they are divided. Then we will subtract the indices and write it as one number. So we will apply all three identities here. So let us look at one at a time. P power minus 2. So this is P QR whole power minus 2. That means it is P power minus 2. So what we have here is P power minus 2 multiplied with Q power minus 2 multiplied with R power minus 2 multiplied with R power 1/3. So basically we opened up this bracket divided by P power A power m whole power n. We multiply the two powers. So 2 multiplied by 1 minus 1 gives us minus 2 multiplied with R power minus 1 multiplied with Q power 3. Okay, so we will see that some of the terms are cancelling each other, that is P power minus 2, P power minus 2. Both are exactly same. Base is same, index is same, so we can cancel them. Let us look at Q power minus 2 and Q power 3. Okay, we cannot cancel here. We have to apply A power m, this one, divided by A power n rule, where m and n are subtracted. So Q power minus 2 minus 3 multiplied to now the R power. Here the two R's are multiplied, so we will add their indices, minus 2 plus 1 by 3, and this R power minus 1 is in the denominator, so we have to subtract minus this index minus 1. Okay, so simplifying this, we get Q power minus 5 and R power. So let us calculate this separately here. Minus 2 plus 1 over 3 plus 1. So it is minus 1 plus 1 over 3. It is minus 2 over 3. So this is R power minus 2 over 3. So there is no P here because it got cancelled. So we can write P power 0 because any number power 0 is 1. So comparing this with the form that we had to show, it is P power A, Q power B and R power C. We identify A, suppose A is 0, B is minus 5 and C is negative 2 over 3. So this is the answer for question number 1. Now to question number 2. On the axis, sketch the graph of y equal to modulus 4 minus 3x, stating the intercepts with the coordinate axis. Alright, so as you all know, the modulus suggests that the value is always positive. Okay, so what does it mean when it is modulus 8? It means 8. What does it mean when the modulus of minus 8? Then also it means positive 8. So we are just concerned about the number alone or the magnitude, not the sign. Okay, so that is the meaning of this modulus notation. So to sketch this on the graph, let us see if the modulus was not there, how the graph would look like? So as you can see, it is a straight line, linear equation, and ends up in a straight line. Okay, so to plot any straight line, we need minimum of 2 lines, 2 points. Okay, so let us locate these 2 points. So when x is 0, what do I get for y? It is y is equal to 4 minus 0, I get y equal to 4. And when y is 0, we get x is equal to, so equate this to 0, you get x is equal to 4 over 3. So these are the 2 coordinate points, that is 0, 4 and 4 over 3, 0. These are the 2 points on this line. So let us plot them. 0, 4, 1, 2, 3, 4. This point is 0, 4 and 4 over 3, which is 1.33. So 1 here, 2 here, so maybe 1.33 here. This is another point, 4, 4 divided by 3, 0. So these are the 2 points on this line. So let us join them to see how the line looks like. So the line looks like this. This is 4 over 3, 0. This is 0, 4. Alright. So now what the changes will happen when we introduce modulus is that the negative part of the y or the line will be converted into positive. So as you can see, the line is positive. That means the y value of the line is positive from this point and above, but this point and below it is negative. So when we introduce modulus, this negative part also becomes positive. That means this part will be reflected back. So this one will look like this. So it was this way, it just gets reflected back. So when the modulus introduced, the graph looks like this. Okay, so this is the graph. So you have to draw the graph and you have to state the intercepts. So one intercept is 0, 4, another one is 4 over 3, 0. So this is the answer for 2A. You have to show this perfect V shape with the vertex at this point. Question number 2B. Solve the inequality modulus 4 minus 3x is greater than or equal to 7. So what does this mean? As we discussed already, the modulus deals with only the magnitude of the expression inside. It doesn't deal with the negative sign. But when we solve the inequality, we will consider the negative sign also. How? Let us see here. So 4 minus 3x is greater than or equal to 7. That is one choice, that is one scenario. Or negative of this value is also greater than or equal to 7. Negative of 4 minus 3x is greater than equal to 7. That is what is the meaning of modulus. Either it is positive or negative, the value, this inequality still remains. So when we get rid of this modulus sign, we will have to consider both positive and negative. I hope you have understood so far. Alright, after that, this is solving of any inequality. So we will solve this further. 7 minus 4 is 3. We multiply by minus 1 both sides. We get 3x, and you know, when we multiply the inequality by negative number, the inequality changes. So greater than or equal to becomes less than or equal to minus 3. So 3x is less than or equal to minus 1. So this is one set of values for x. The another set can be minus 4 plus 3x is greater than or equal to 7. 3x is greater than or equal to 7 plus 4, 11. X is greater than or equal to 11 over 3. Okay, so the solution set is x less than or equal to negative 1 and x greater than or equal to 11 over 3. Now the question 3. This question is about vectors. I hope you guys find vectors easy. Most of the rules of vectors just follows the algebraic rules. only that you have to take care of the directions. I hope you know this already, so let's go ahead and solve this question. The diagram shows the quadrilateral OABC such that OA is A, OB vector is B, OC vector is C. The lines OB and AC intersect at point P such that AP is to PC is equal to 3 is to 2. Find OP in terms of A and C. Okay, so we have to find OP. Now to find OP, we can use the triangular formula of vectors. Okay, so what is the triangular formula of vectors? Let's say a vector, one vector A is like this, another vector B is like this. The resultant of these two vectors is given by the third vector like this, which represents A plus B. So you can think of it like this. A person starts walking from here, he reaches this point. Then he walks from here, he reaches this point. So if I ask you as a result from where to where he walked, so you will coolly answer me that he walked from this point to this point. Which path he traversed, which direction he took, but doesn't matter. Finally what matters is where he started from and where he has reached. So this vector is the resultant of A and B, which we will represent it as A plus B. So this is also called as triangle formula of vectors. So we will apply it here. So let us consider the triangle OAP. Triangle OAP. In this triangle, we apply the formula OA plus AP is equal to OP. Alright. So OA is vector A, AP is vector, it is part of the vector AC, and AP is 3 parts, PC is 2 parts. So total 5 parts. So if I have to write here, AP is to PC is 3 is to 2. So as you can see, total AC is 5 parts. Okay, out of that AP is 3 parts. So we will write 3 out of 5 of AC. That is equal to OP. Now we will substitute AC 3 over 5. So we don't have AC vector, we will have to calculate that. So again we will apply the vector formula here. How can we calculate AC? So in the triangle OAC, in the triangle OAC, we can apply the triangle formula like this. OA plus AC is equal to OC. So you can also remember it like this. OA. The second vector should start with A again. So what remains? The resultant vector is the first letter of the first vector and the second letter of the last vector. That will be your resultant. Remember, you can remember that way also. So from this equation, AC is equal to OC minus OA. So OC is given as C and OA is given as A. So it is C minus A. So we will replace AC as C, vector C minus vector A. And this is equal to OP. So simplifying, we get vector A plus 3 over 5 vector C minus 3 over 5 vector A. Now we can combine the two vectors A and 3 over A. So it is 1 minus 3 over 5, we get 2 over 5 A plus 3 over 5 C is OP. So this is the answer for part A, that is write OP in terms of A and C. To part B, given also that OP is to PB is 2 is to 3. Alright, so this information is very useful for us. OP is to PB is 2 is to 3. Show that 2B is equal to 3C plus 2A. Alright, so let us start with the expression that we got. In the previous part we got OP as 2 over A into A vector plus 3 over 5 into C vector. This is what we got from the part A. Now OP can also be, from this data, OP can also be 2 over 5 parts of OB, which is 2 over 5 of B vector. Now from equations 1 and 2, we can equate the right sides. So 2 over 5A plus 3 over 5C is equal to 2 over 5B. What we get is 2 into A vector plus 3C vector is equal to 2B vector. Hence shown. Or you can say hence proved. Wait, let's start with question number 4. A curve is such that d square y by dx square, the second derivative, is given as 3x plus 2 to the power minus 1 over 3. So the curve is given such that its second derivative is like this. The curve has gradient 4 at point 2, 6.2. Find the equation of the curve. Alright. So equation of the curve, we have to get an equation for y, equation in the form y equal to. So from d square y by dx square, we have to get y. That means we have to integrate once, we get dy by dx. We integrate dy by dx again, we get y. So there are two steps here. Let us start with the first one. So dy by dx is equal to integrate 3x plus 2 power minus 1 over 3 with respect to dx. Okay, so here the identity that you need to know is ax plus b power n into dx. How do we integrate this one? So we integrate this one like this. You write the expression as it is, the power you increase by 1 and divide the expression by the same power. Then look at the coefficient of x, which is a, and divide it by that number. So going with that, the integration will be 3x plus 2 minus 1 over 3 plus 1 divided by the same increased index will come here along with the coefficient of x, which is 3, plus the constant of integration. So simplifying this, we get 3x plus 2 power minus 1 over 3 plus 1 is 2 over 3 divided by 2 over 3 into 3 plus c. Okay, so we will simplify it further from here. 3 and 3 will cancel. So this simplifies to 3x plus 2 power 2 over 3 divided by 2 plus c. Now if you want the complete expression for dy by dx and hence for y, we need to find the value of this constant of integration. Now for that we will use a data given, that is the gradient is 4 at 2, 6.2. So one coordinate is given. At that coordinate the curve has gradient 4. Now as you all know already, dy by dx gives us an expression for finding the gradient of a curve at a given point. So we will make use of that. So when it is x is equal to 2, so when x is equal to 2, dy by dx is equal to the gradient 4. So we will use that here. So dy by dx I am going to substitute as 4 equal to x I am going to substitute as 2. So it is 3 into 2 plus 2 power 2 over 3 divided by 2 plus c. So 4 equal to 3 into 2 6, 6 plus 2 8. So this becomes 8 power 2 over 3. So how do we simplify 8 power 2 over 3? So this power 2 over 3 I will split it as 1 over 3 whole multiplied whole to the power 2. So we have seen in the previous example how to handle the indices like this. It will be multiplication. A power m whole power n is always a power mn. So mn I can always split it as m and n. So any number to the power 1 over 3 means its cube root. So 8's cube root is 2 square. So the answer is 4. So this is 4 divided by 2. I get 2 plus c. From this equation it follows that c is equal to 4 minus 2, that is equal to 2. Okay, now to the next step of finding an equation for y. So to find y from dy by dx, we have to integrate dy by dx with respect to dx, which means integrate 3x plus 2 power 2 over 3 divide by 2 dx plus 2 dx. Okay, so integrating the first term, what we get is 3x plus 2 power 3 plus 1 divided by the same power 2 power 3 plus 1 here. Then differentiation of the term containing x. So when you differentiate 3x, what we get is 3, which goes in the denominator, then this number 2 here, plus when you integrate a constant, you have to introduce an x with it, so it becomes 2x plus a new integration constant, let us call it t. The simplification will lead us to 3x plus 2 power 5 over 2 divided by, you will observe that this is 5 over 3, this is 5 over 3, that 3 will cancel with this 3, so 5 into 2 is 10 plus 2x plus d. Now one last step remaining, that is to find the constant of integration. To find the constant of integration, we will make use of the point, one of the points given, that is 2, 6.2. This is one of the coordinates on the curve given. So we will substitute x equal to 2 and y equal to 6.2 in this equation to find d. So y equal to 6.2 is equal to 3 into 2 plus 2 power 5 over 3 divided by 10 plus 2 into 2 plus d. So this is 6 plus 2, 8. 8 power 5 over 3. We can split it as 8 power 1 over 3 whole power 5. So as we have seen in the previous step, 8 power 1 over 3 is cube root of 8, which is 2, and that is power 5. So 2 power 5 gives us 32. So this is 32 over 10 is 3.2 plus 4 plus d. This is 7.2 plus d. From here it follows that d is equal to 6.2 minus 7.2 is minus 1. This is the final expression for the equation of the curve, and that is the final answer for question number 4. Great. Let us start with question number 5 now. So an expression in log is given. We have to find the value of p. Log p to the base a plus log 5 to the base a minus log 4 to the base a is given as log 20 to the base a. Find the value of p. Okay, so we know the logarithmic formulae. Log a into b can be written as log a plus log b. Similarly, log a divided by b, we can write it as log a minus log b. So we will be using these two here. So consider the first two terms. The bases are same. So see the right side here. So bases are same. Two separate logs can be combined into one log like this. So these two terms we can write it as p into 5, 5p to the base a minus log 4 to the base a. Now here we will apply the second one. We will combine both of them and we will write it as 5p over 4 to the base a is equal to log 20 to the base a. So log to the base a on the left side, log to the base a on the right side. we can safely ignore the logs and can write that the expressions are equal to each other on the left and right side. So that P becomes 20 into 4 divided by 5, which is 80 divided by 5 is equal to 16. So that is the value of P. Now on to part B. Solve the equation 3 power 2x plus 1 plus 8 into 3 power x minus 3 equal to 0. So as we write the equation, we can observe that 3 power x and 3 power 2x and 3. So we see 3, 3, 3. So that should give us a quick idea that we can separate 3's and we can rewrite this equation in terms of 3 power x's. Let us see how we can do this. So 3 power 2x, we can write it as 3 power 2x into 3 power 1 plus 8 into 3 power x minus 3 equal to 0. Now this is nothing but a quadratic equation. How? Let us say 3 power x is y. Then what is 3 power 2x? This is nothing but 3 power x whole square. Remember the index rule. A power m whole power n is a power m multiplied by n. So here a power m multiplied by n we can split like this. So substituting it back, we will see that this is y square. So 3 power 2x is y square. So I can write it this one as 3y square plus 8 into 3 power x, which is y, minus 3 equal to 0. So we got a quadratic equation. So we can solve this quadratic equation by the formula method as minus b plus or minus square root of b square minus 4ac divided by 2a, where a is 3, b is 8 and c is minus 3. These numbers here. Okay, so substituting, we will get minus 8 plus or minus square root of 8 square minus 4 into a into c divided by 2a. So solving this, we will get two values for y. One is minus 3, while considering plus sign we get minus 3, and when we consider minus sign we get 1 over 3. So now we will substitute value of y back. We get 3 power x is minus 3 or 3 power x is 1 over 3. So this is not possible because 3 power x, so whether it is x is positive number or negative number, the 3 power x can never be a negative number. So we can test that 3 power positive number. So you can see that clearly any positive number will give us a positive result. Whereas if x is negative, suppose x is minus 1, it is 3 power minus 1, we get 1 over 3, which is still a positive value 0.33. X is minus 2, we get 3 power minus 2, which is 1 over 9, again we get a positive value. So this equation doesn't hold good. So we will discard this value, not possible, hence discarded. So we end up with 3 power x equal to 1 over 3. So this can be written as 3 power minus 1. So from here it follows that x is equal to minus 1. Now to the third part of question 5. Solve the equation 4 log 2 to the base y plus log y to the base 2 is equal to 4. This is very simple if you know one of the logarithmic identities. And what is that? Log a to the base b. We can change the base and this number by just inverting the log. So it will be 1 over log b to the base a. So we are going to apply here because we can see y and 2 are interchanged in their positions. So we will do that. So 4 log 2 to the base y, we will change it to log y to the base 2 plus this is anyway log y to the base 2 is equal to 4. So we will take the common denominator as log y to the base 2. It is 4 plus, we multiply these two, so it becomes log y to the base 2 whole square is equal to 4. Simplifying further, it is 4 plus log y to the base 2 whole square is equal to 4 log y to the base 2. Now we will simplify this by assigning log y to the base 2 as x, and see the wonder what we get. It is 4 plus x square is equal to 4x. So this is easily a quadratic equation which we can solve. So rearranging, we get x square minus 4x plus 4 equal to 0. So this can be solved by simply factorizing. So the two factors are x minus 2 and x minus 2. So from here it follows that x minus 2 equal to 0 and x is equal to 2. So this quadratic equation has two roots, and both roots are same. It is plus 2. So now we will replace x with the assignment that we made. So remember, we made x is equal to log y to the base 2. So replacing it back, what we get is log y to the base 2 is 2. Okay, so from here it follows that y is equal to 2 power 2. So this base raised to this power is equal to this number here. So you need to remember the basic definition of logs, that is log a to the base b if it is n, then b power n is equal to this value here. So going by that, y is 2 power 2, which is 4. So we solved the equation and found the value of y to be 4. So this is the answer for 5C.
Thank you for being there in my classroom today. If you need any clarifications on any of the questions that we solved today, you may contact me on my channel in Discord. For more details, please refer to the description box below. Thank you.